Welcome to 8th video of Analog Electronics Lab. In this we should see how do we interface LDR to an Arduino to control the bulb now. Now here we are asked to write an Arduino script to sense the signal from a LDR sensor and turn on the bulb if it is dark. Now the sensor used is light dependent resistor, that is known as LDR. The actuator is a bulb which will operate with 230 volt. The task is to turn on the bulb when it is dark. So when the light becomes very less, now we are supposed to turn on the bulb. So implementation is using the Arduino board. Now resistance of LDR is more when the light is very less, that is when it is dark. So when it is light is falling on the LDR, the resistance is very small. So R of LDR is in terms of tens of kilo ohms when it is dark. So it is now I can say it is tens of kilo ohms or hundreds of kilo ohms when it is dark. The same resistance of the LDR will be hundreds of ohms when the light is bright. Bulb is operated using a 230 volt AC signal. Now we have to understand here is that the resistance of the LDR is very high when the light is not falling on that. When the light falls on the LDR, the resistance is very small. Now here LDR can be used as a part of a potential divider to sense the change in the resistance of the LDR. So you can't take the resistance of LDR directly. It should be used as a part of a potential divider so that you can sense the intensity of light. Now one of the possible choices, you can put the LDR in the lower part of this potential divider. So you can have 100 ohm here and the LDR can be there in the lower part. So as we know that suppose if you say that this is the voltage which we call it as V sense 1, which is nothing but VCC into R of the LDR divided by 100 ohm plus R of the LDR. Now we know that when it is dark, the resistance of the LDR is very large. So since it is in series with 100 ohm, the entire voltage will be available at V sense when the LDR, when the light is dark, when there is no light falling on the LDR. So that's why it is V sense is almost equal to VCC. So when the light is not falling on this, when the light falls on this, so the resistance of the LDR is very small, maybe in terms of hundreds of ohms. Since we have a 100 ohm here, so this is also assuming that is 100 ohm. So this will be less than VCC, maybe half of VCC. Assuming that the R of the LDR is 100 ohm, when light falls on this, so we have 100 ohm in series with 100 ohm. The resistance, the voltage at V sense 1 will be equal to almost equal to half of VCC. Now this is the voltage change at V sense 1, which will be used to sense the voltage which will be connected to the Arduino board. Now see, now when it is dark it is VCC, when it is light is falling on that, so it is less than VCC. So other possibilities, you can have the LDR on the upper part of the potential divider, the lower part can be 100 ohm. So as we know that as per the equation, the V sense will be VCC into 100 ohm divided by 100 ohm plus R of LDR. So when it is dark, the resistance is large here, so the entire voltage will drop here. So we are left out with a very small voltage here. So V sense will be very small when it is dark. When V sense is when the light is very bright here, so it's almost equal to 100 ohm. Assume that. So we're going to get almost equal to half of VCC. The voltage here will be either very small or close to half of VCC. In this type of configuration, if the configuration is like this, the resistance or the voltage V sense will be equal to either VCC or half of VCC. Either we can use this as a sensing element or this as a sensing circuit. Now, so to check the V sense, depending on the choice of the LDR connection, correspondingly look for the value of the analog voltage. So analog voltage V sense 1, V sense 2 varies depending on which choice you are looking for. If the choice 1 is used for the LDR connection, if V sense is almost equal to VCC, then the logic 1 will be read on the logic 1 will be sent on the digital IO so as to turn on the bulb. So when it is when Vsense is equal to VCC, meaning that we're going to get the condition will be corresponding to, okay, assume that Vsense is equal to Vsense1 is equal to VCC, this will be dark. So we are supposed to send logic 1 to turn on the bulb. So here you can see, if you are using second choice, this is dark. So when it is dark, the voltage is less. The voltage goes less, so then we are supposed to make it equal to logic 1 so that you can turn on the bulb. So this way, depending on what is the connection you are making, you have to accordingly change your code. So this is the Arduino board as we looked in the previous cases. So we have A0 to A5, we can connect it to any one of them, the Vsense output, and any one of these can be used as the output. Now this is the driver IC. So as we look in here, this has got 4 channels, 1, 2, 3, 4, having 2 enablers and VCC1, VCC2. I'll repeat, VCC1 is for this IC, which will be 5 volt, whereas VCC2 is for the driver or the relay or the motor, whatever you're using. If it is DC motor, you have to connect to 12 volt. If it is a relay of 12 volt, you are supposed to connect to the pin number 8, 12 volt. Now this is what we already seen, and this is the possible connection what you can make. Suppose if you are using, either you have to use this LDR connection or this LDR connection, so that will be connected to the Arduino board, either A0 to A5, any one of them, and the output is connected to the L293D. So one of the input of the channel, the output is, you can see it's connected to the relay coil. If this sensor senses, supposing that you use this combination, when it is dark, this will almost become VCC. When it almost becomes VCC, make this equal to 1. So when this is 1, so it will going to energize the coil. So when it energizes, the bulb will going to turn on. So the similar connection can be done using the relay, the transistor also. We can replace L293D by this connection. This is how the bulb is connected. I can see this is the coil what we have. The NO is connected to one of the broken line of the bulb. The other line is connected to the common. So when current is not going through this, so it will be under normal condition off. When current flows through this, so we have to ensure that current should flow when it is darkness. So when it is dark, the current flows through this, so this will be get connected to this so that the bulb turns on. You can see this is the code. We are using pin number 13 to energize the coil, which we name it as bulb here, and that's why it has been defined as bulb as an output mode. So we are using a serial port so that we can see the voltage that is sensed from the LDR. So this is we have just a minute. Okay, this is what we're looking at. So this is used to sense the, so once whatever voltage that is coming here, so you can have a look at what are the voltage that is coming over here, so that you can read it to val, and the serial dot print val will going to display the value of red voltage. Now depending on the type of connection you are making, so I will not say that okay, for 900 it will work for both the cases. Now depending on the resistance whatever you used in that potential divider along with the LDR, so this value, the condition to which the value is verified, so may be changed. So this need not be 900 in all the cases. And if it is greater than 900, meaning that when it is dark, you put a high so that bulb turns on. If it is less than 900, meaning that it will be light is there, so you're not supposed to turn on the bulb. So that's why this is high when the statement is false. So the bulb is energized with a 0, so that bulb is off. So that will be the condition when you have certain brightness falling on the LDR. So this way we can comfortably do this experiment to sense the LDR to turn on the bulb when it is dark.